5, and this is on Organic 2. I think this is the one that most students fear because it's on alcohol, carboxylic acid, and ester. So let's dive into things. And we're going to look into the first question, which is a very general question on homologous series. This is essentially, in my opinion, a little bit of memory. Okay, so they want you to talk about characteristics of homologous series. Now, essentially, there are 5 possible answers as you see in red, green, and blue, but there are some keywords that you need to take note of. Okay, so in the question stem itself, they have not mentioned anything about homologous series or any characteristics, so you are able to name any 5. Okay, so the easiest to name is actually the first two, same general formula. So if you're looking at, for example, alkene, which is the CC double bond, general formula will be CnH2, and this is what we mean by general formula. Our functional group for alkene would be this CC double bond. Okay, so if a molecule belongs to the alkene family, they will have this functional group and they will have the same general formula. However, if you're feeling adventurous, you can look into the green wording such as similar chemical property. So if you're talking about chemical property, things that you need to take note of is the keyword in front of it. If they are in the same family, they do not go through they undergo reaction with the same type of reactant, but the end product is different, so we can't use the word same chemical property, we have to use the word similar. Okay, and if you are looking at writing physical property, then you have to use the word trend. The reason for trend is because due to the difference in molecular size, the value for their melting point, boiling point, viscosity, density will also differ a little bit. So we have to use the word trend, we cannot use the word same. All right, and if you're looking at the fifth one, possible answer is consecutive member differ by the next one, the difference is 1 carbon and 2 H's. Okay, all right. So another common misconception here is, or rather misuse of words here, is of using the word same general formula. So don't use the word same molecular formula, which is totally different. Molecular formula is basically the actual thing. Like for example, C2H4, C3H6. These are molecular formula. General formula are things like this. Okay, so alkene would be this. Alkene would be CnH2n plus 2. General formula is different from molecular formula. So take note of your wordings when you are giving this characteristics of homologous series. So 2 marks there if you have given the first two clearly. All right, then we look into methanol. So now we have our alcohol heated with potassium dichromate. This is essentially our oxidizing agent, and they say the other agent. Then they say ethanol is oxidized to methanoic acid. So essentially, this process is oxidation, and oxidation require a catalyst. This catalyst is our sulfuric acid. Okay, you are so in this question, things to take note of is they say give the formula. So if you give the name, there'll be no marks. Okay, so again, take some time to look at the question demand, the command word. They want formula, then don't give the name. Okay, on the same note, there are students who have recalled wrongly the catalyst in the oxidation of alcohol to carboxylic acid. So the CE basically means common error. These are the common error that students have proposed. So take note of the different catalysts, the different condition required for organic Chem 2. So if it's potassium dichromate, what is the color change during the reaction? The way I remember this is I use the O in the dichromate to help me recall the original color. Okay, and I always, for unknown reason, I always think about carrot when I think about potassium dichromate. So I know that it starts with orange and it will turn green, right? Because if I were to draw, oh no, I shouldn't draw this color. I should use this, and then I draw green. Okay, so it starts from orange, it turns green. So find a way to remember the different colors as well in organic chem. There's one more question coming up, and we look into the difference in color. Okay, so what are the common wrong color that students tend to recall? They tend to talk about pink to colorless. That's actually the color of phenanthylene. Phenanthylene is an indicator that tells us the color change in acid and alkali. Some students have also misquoted brown, and brown is the color for bromine, reddish brown actually for bromine. for aqueous, not aqueous, but bromine in its elemental form. Okay, so take note of the wrong color that students tend to write, and find a way to remember these color changes. Okay, so next we're going to draw methanol. Methanol, as the name suggests, meth means 1C. So if it's only 1C and it's part of the alcohol family, you need to know that there's going to be OH and it's only 1C. Okay, so when you are doing drawing, there are things that you should do for yourself. You should check that each carbon should have 4 bonds. So take a look at the carbon around here. So I've got, I should use red, right? Okay, so I've got 1, 2, 3, 4 around the carbon. Each hydrogen should have 2 bonds. So you can see that this and this next to the oxygen. And then each hydrogen should only have 1 bond. So these are things that you should be checking when you're doing your drawing. Again, I'm going to encourage you to draw with pencil. Okay, so to be pencil, get ready. Next thing we have to draw methanoic acid. Methanoic acid, the general formula is CnH2n plus 1 COOH. The smallest n value is actually 0. So to get to methanoic acid, you actually have to input the value of 0 into all the n's here. So there will be no C, and then you put H20 plus 1. Technically, you only end up with 1 H, right? Then followed by COOH. So if you were to draw this out, you will have this structure that you see over here. But taking note that the functional group for carboxylic acid is this COOH with one of the O double bonded to the C. So you need to have this functional group clearly shown in methanoic acid. Okay, so that's our drawing for methanol and methanoic acid. And then we'll look at the next part of the question, which is going to dive into the production of ester. Okay, so here we look into methanol reacting with methanoic acid. Maybe I should use different colors. So this is methanol, and methanoic acid is over here. So things to take note here is if it's methanol is over here, yeah, okay, and methanoic acid is over here. Okay, maybe I should use green. Okay, the carboxylic acid loses the OH group, and the alcohol loses the H, okay, next to the O. So when these two small parts are being lost, it actually forms the production of water, as you can see over here. Okay, so what happens here is if you take away, I'm going to take away the pixel. Okay, take away this part, and you take away this part of carboxylic acid, and you fuse them together, you will end up with this ester over here. The COO refers to this COO here refers to the ester linkage, which will look like this. Okay, yeah, or rather, it will be this part of the molecule. Okay, so this is how we write the formula. And you will want to check for balancing as well. So things to take note of after you write the formula is that you will have two C's. Okay, and the two C's are over here. I'm going to highlight to you the two C's. Then you will have 6 hydrogen, which I'm going to use yellow. 6 hydrogen. 1 plus 3, that's 4, and then 5, 6. And then we've got 3 oxygen, which is 1, 2, and then 3. Okay, so after you write the formula, also check on your balancing as well. Okay, so this part D is one question that, although it looks like a very simple question, it's not the easiest for a lot of students to score. It's an MCQ question, but you really need to break it down. So how do you do this question here is focus on, I'm going to ask you to use this question and you focus on the COO words, the placement of the COO, because that's basically where you should split the molecule. Okay, so COO. Okay, this part here in green, the green box here, over here, this is basically where your carboxylic acid is. Okay, because this C double bonded oxygen, okay, that's where the functional group of carboxylic acid used to be. So this is where your carboxylic acid is. And since there's 2 C's over here, as you can see, 1 C and 2 C's, this is a ethanoic acid. This is an ethanoic acid. Okay, then we look into the other part. I'm going to take away my drawing here. Wait, I'll change it to pixel first. It's easier. Okay, then I'm going to ask you to look into the remaining part of the formula, you will see that this would be from the alcohol. Oh, there we go, from the alcohol, and there are 4 C's around, so that means it's butanoic acid. So let's take a moment. Meth, eth, prop, and but. Okay, so most students remember the number of C's based on this meth, eth, prop, but, but monkey eat peanut butter. I think I constantly hear my students say this. Okay, monkey eat peanut butter as a way to remember meth, eth, prop, and but. So if it's 4 C's, then it's butanol. So that what should be the correct answer means in order for us to name ester, okay, the first part of the ester name comes from the alcohol. So if it's made from butanol, that means the first part should be butyl, right? And then if the carboxylic acid that it is made from is ethanoic acid, then the ester name will be ethanoate. Okay, so it is butyl ethanoate. So that means A should be the answer. So there are a few questions like this. 1 mark question, MCQ, similar context. They just change the ester and they ask you to work out the name of the ester. The first step you need to identify is where the COOH is, and you break it down into what is the original carboxylic acid, and then what is the original alcohol, and that's how you can formulate the final name. Okay, so first step is always to find the COO first. Okay, and finally you need to deduce the molecular formula of acid. So what you see here, is the structural formula. Structural formula is basically writing based on the number of C's. Yeah, so here we got 1, 2, 3, 4, 5, 6. Got 6 different C's, and what's around the C's, that's how we write the structural formula. But for molecular formula, you can just put the number of C's together. So total of 6 C's, 12 H's, and O2. What are some common errors that students tend to write here is they miscount the number of C's, or they give empirical formula instead. Now, empirical formula is what we call the simplest ratio, the formula of the simplest ratio. So in this case, student, if you simplify it, it becomes C3H6O, and that shows misunderstanding of the concept. You will not get any marks here. Okay, so this is a 10-mark question on organic 2. How do you find organic 2? Do you need a little bit more question to support you with organic 2? If you do, please let me know. I'll be happy to use another year to work on this. 10 marks is usually the baseline for organic 2. I've seen harder questions for this as well. So if you have any question, just DM me, drop me a question, then I'll be happy to even give you, if you can just do a question and let me mark. I'll be happy to look at it for you. Okay, that's all.